The universe is vast, so vast that it's easy to forget that nothing within it stays still. From the smallest particles to the grandest galaxy clusters, everything is in motion. But where are we all going? What force or forces are guiding this cosmic journey? To answer these questions, we have to step back in time and look at the universe's evolution, and even into its distant future. The origins of motion. Billions of years ago, when the universe began with the Big Bang, everything was packed into an incredibly small, dense point. At that moment, space itself began to expand, and all matter and energy burst outward, setting everything in motion. But this wasn't just a random explosion. From the very beginning, gravitational forces began shaping the cosmos, pulling matter into clumps that would eventually become stars, galaxies, and galaxy clusters. In those early moments, tiny variations in density appeared in the universe. These slight imperfections became seeds from which galaxies and superclusters grew. Gravity, the force responsible for pulling objects together, started to take hold, gathering gas and dust into ever larger structures. Over billions of years, galaxies formed and began to cluster together, eventually creating the cosmic web, a network of galaxies and voids that stretches across the universe. But even though these galaxies had formed, they weren't stationary. Instead, they were set in motion, pulled by each other's gravity and by larger forces at work across unimaginable distances. The Milky Way's journey. The Milky Way, our galaxy, is just one of many caught in this grand motion. As it formed, it started moving through space, guided by gravitational currents. Like a ship adrift on an endless ocean, our galaxy travels along an invisible river, drawn by unseen forces far beyond its borders. At the center of the Milky Way lies a supermassive black hole, and all the stars in the galaxy orbit around it. But the motion of stars within the Milky Way is only one part of the story. The entire galaxy itself is also on the move. It's not just rotating on its axis, but is part of a much larger flow, pulled by the gravity of other galaxies and massive structures in the universe. What is the Great Attractor? As scientists began studying the motion of galaxies, they noticed something strange. The Milky Way, along with its neighboring galaxies, seemed to be moving toward a specific point in space. This point, known as the Great Attractor, was exerting a powerful pull on everything around it, but what it was remained a mystery. The Great Attractor is a region of space that has a massive gravitational influence on nearby galaxies. Although we can't see it directly, because it lies behind a thick veil of gas and dust in our galaxy, we can measure its effects. Galaxies are being drawn toward it at astonishing speeds, and that includes our own Milky Way. But even though we know where we're going, the question remains, what exactly is pulling us? The cosmic web, galaxies bound by gravity. The answer lies in the structure of the universe itself. The universe isn't just a random scattering of galaxies floating aimlessly in space. Instead, galaxies are arranged in a vast network called the cosmic web. This web is made up of filaments, strands of galaxies and dark matter that stretch across billions of light years. In between these filaments lie enormous voids, regions of space with very little matter. The cosmic web is the result of gravity pulling matter together over billions of years. As galaxies form and move, they are guided by this web, clustering in certain areas and avoiding others. The Great Attractor is one such region, a massive node in the cosmic web where the pull of gravity is strongest. But the Great Attractor is not the end of the story. As scientists have looked deeper into the universe, they've discovered even larger structures beyond it. Superclusters of galaxies, bound together by gravity, span across hundreds of millions of light years. Our Milky Way is part of one such supercluster, known as Laniakea, which means immense heaven in Hawaiian. Laniakea contains over 100,000 galaxies, all of them flowing toward a central point, much like rivers flowing toward an ocean. Galactic mergers, a cosmic dance. One of the most exciting and violent processes in the universe is the collision of galaxies. Our own galaxy, the Milky Way, is on a collision course with its nearest large neighbor, the Andromeda galaxy. In about 4.5 billion years, these two galaxies will meet, and their stars, gas, and dust will intermingle in a slow, chaotic dance. Galactic collisions are not as sudden or destructive as they might sound. When galaxies collide, the stars within them are so far apart that direct collisions between stars are extremely rare. Instead, the gravitational forces between the galaxies pull and distort their shapes, creating spectacular tidal tails and triggering bursts of star formation. Over billions of years, the two galaxies will eventually merge into a single, larger galaxy. This process of galactic mergers has been happening for billions of years, and it will continue far into the future. In fact, the Milky Way itself is the result of numerous smaller mergers that happened long ago. But even after the Milky Way and Andromeda merge, the journey won't stop there. The new galaxy will continue moving, drawn by the same forces that have shaped the universe since its birth. The role of dark matter and dark energy. As we observe the universe, it becomes clear that visible matter, stars, gas, and dust, makes up only a small fraction of the total mass. The rest is something we can't see, dark matter. This mysterious substance doesn't emit or absorb light, but it exerts a gravitational pull, helping to hold galaxies together and shape the cosmic web. Without dark matter, galaxies would not have formed as they did, and the universe would look very different. But dark matter isn't the only invisible force at work. There's also dark energy, a mysterious force that is causing the expansion of the universe to speed up. Dark energy is even more puzzling than dark matter, because while dark matter pulls things together with gravity, dark energy is pushing them apart. As the universe expands, galaxies that are not gravitationally bound to each other are being driven apart at ever-increasing speeds. This means that in the distant future, galaxies that are currently part of our cosmic neighborhood will drift so far away that their light will never reach us again. The universe will grow darker, colder, and more isolated as dark energy continues to dominate. The fate of the universe. What does this mean for the future? Where is everything going in the long term? If dark energy continues to drive the expansion of the universe, we're heading toward a future where galaxies become more isolated. Stars will burn out, and new stars will form less frequently as galaxies run out of gas to fuel star formation. Over trillions of years, the universe will slowly fade into darkness. But this distant future is not one we need to fear. For now, we are still in an active, dynamic universe where galaxies are merging, stars are being born, and cosmic structures are still forming. Our journey through space continues, guided by forces both seen and unseen. A universe in constant motion. At every scale, from the smallest particles to the largest galaxy clusters, the universe is in motion. Earth orbits the Sun orbits the center of the Milky Way, and the Milky Way is drawn toward the Great Attractor.